Good evening, everyone. Welcome to Group 2, Tonga Group 2 presentation based on the topic, the size, abundance, and sediment composition at the Hatafu Beach. The objectives. The purpose of this experiment is to examine the size, abundance, and the composition of the sediments at the Hatafu Beach formation. Here are our group members. We have 4 members in our group. They are Eleanor Maile, Sonetu Pou, Kepuel Maile, and Elizabeth Pua. What is sediments? Sediments is when the rocks are broken down into fragments, either through the mechanical process, such as weathering, or through chemical reactions. Sediments are either classified as clastic or chemical, meaning that the rocks are broken down through either mechanical or chemical reactions. As you can see here on the map, the locations of the area that we have based our field trip on, which is located at the western side of Tonga, as shown on the map. Here are the following materials that we used during our field trip. On the site that we're basing our experiment on, we use a measuring tape, plastic bags, and a label. Materials from the laboratory consist of sieving can, top and balance, microscope, and IT book. Here are the following steps that we used to while doing our experiment. The first one, we stretched a transect line with 20 meter long, starting from the vegetation region towards the swath zone, and locate every 5 meters on the transect. We collect a sample of about 500 grams on each 5 meters and store it in a plastic bags. We then to observe and examine the sediment size, the abundance on every 5 meters of the transect line. Step 3, the sediments was filtered through a sieve into 4 different sizes before weighing. And we analyzed the sediment and count the type of sediments present on the 4 different sizes of the sieve and record it in a form of tables and graphs.
Thank you. We continue to our result they got from our research. According to the table, so the one is very dominant. The amount of sediment when after separated, the 0.5. This is the one that is very most dominant at the 0 meter. When come up to the 5 meter, it's same with the 0 meter. The 0.5 millimeter is very dominant, around to the 20 meter. Except the 20 meter, the 4 millimeter, that's the one is mostly dominant and very high size. Come up to the graph of the amount of sediment when weighting. According to the graph, the 4 millimeter, this the one is very high. Come up to the 0.5 millimeter is come to decrease, and also the 0.5 meter, according to the sample they take from 0 meter up to the 20 meter. The 0.5, this the one is very dominant. Come up to the next table. They show the percentage of sediment they found in the Hatafu Beach profile. They all show in the color, the color in green color. This the one is very most dominant at the beach profile. And Also, the morass, forum, and the smallest percentage is a rock fragment. Come up to the graph, the amount of sediment and abundance at the beach profile. They all know it shows in the graph from different sample. Sample 1 to sample 5 is located the green color. That is the color. This is the color. This is the one is most dominant from each sample. And also the morass, forum, and the last one, the rock fragment. Thank you.
Thank you. In the discussion of the results, according to Table 1, Hatafu pitch profile is composed of various types of sediment, whereas coral dominate. The abundance of the sediment along the span is shown in Table 3. The other fragments are mollusk forams and rock fragments, which contribute in the formation of this profile. The distribution of the size of sediment is similar from the vegetations at the top down to the beach face or the swash zones at the transect. The larger size of sediment is most dominant at the swash zone, according to Table 3, and coral fragment is mostly found at this beach profile. These coral fragments are lighter enough to be carried around by the wave energy, and that's why it's most occurred at swash zone. The result is supported by Tonga Tapu is a coral island made up of limestone, which is surrounded by platforms of coral. Wave energy also contributes to the sediment compositions, as it is very high on the headlands, and it refracted the sediments that result in more deposition of coral at the Hatafu beach profile. Tonga has southeast trade winds, where Hatafu beach profile contain not much wave energy and wind energy, except when in response infrequent and high magnitude extreme events such as tsunami and storms to affect the profile at Hatafu beach. The erosions of the coastal cliff helps in formation and sediment composition of this beach profile, where it shows on some rock fragments were found on the sediment or at the beach. In some situations, because of extreme events are infrequent, they make a relative small contributions to the overall sediment dynamics. The main driver of the Hatafu beach profile sediments are wave energy. There are few sediment pass through the 0.25 millimeter of the sea, where it proved that most of the sediment size are as suspended loads that are very light to be carried by wave energy and set up them into the sea. Some possible error when collecting the sediment, it may be because during collections of sample, most of the sediment were taken only from the surface layer of the transect. The other possible area was that the sediment must dry in the sun to remove excess water because it affects the result. Also, in relation with other research review, the finer sediments are most deposited on the sea, where there is no wave energy, and it's proved from our result that not much sediment passed through less than 0.5 millimeter in the sieving can.
Thank you. Now it's a conclusion. In the conclusion, the dominant sediment is coral fragment, which is related to the formation of Tonga Tapu Island, which is Tonga Tapu Island is a coral reef island. Apart from examining the size, abundance, and composition of the sediments, it also highlights from the result the main driven of the sediment on this site are mainly caused by wave energy and wind, except for some response to infrequent and high magnitude extreme events such as tropical cyclones. At a long-term effect, sea level rises done the most of changing in the profile and the formation of the Hatafu Beach profile. Thank you. Now it's a time for question. Is there anyone have any question?
Thank you. Can you elaborate on the main driven of sediment in Hatafu Beach profile, please?
The main driven of sediment here at the Hatafu Beach profile was wave energy. There are other forms of energy which contribute in the sedimentations of Hatafu Beach profiles like winds, some extreme high magnitude events like tsunami and storms, but waves is the main driven of sediment here at Hatafu Beach profile. Any other question?
Why coral fragments dominate the sedimentation of this beach profile?
Thank you. As we mentioned in our discussion of our result, coral was the dominant sediment size in this beach profile because Tonga Group Islands is a coral islands mainly made with limestone, and also it is surrounded by a platforms of coral which result in most of the sediments are coral. Any question? No, thank you. Okay, thank you, Malo Alpito.